So we're in section about inverses. All right, we've got f of x equals the square root of x minus 2. We've got a bunch of parts to complete. Notice the first part wants us to find an equation for f inverse of x. So that's our steps that we're going to do. Part B, they want us to graph. That's probably matching, but we'll actually do the graph. And then part C, we're going to use interval notation to give the domain and the range for both f and f inverse. All right, so here we go. First part, we've got f of x equals the square root of x minus 2. All right, let's take a look at that. That's y is equal to the square root of x minus 2. And you know what? Since we have to graph and we have to find the domain and range, let's just graph that very quickly. That's going to help us think through this process. Okay, the square root of x minus 2. We all know what the square root looks like from learning our toolkit functions. The minus 2 means you move 2 to the right. Okay, so if I move 2 to the right, now that's what that function looks like. Let's go ahead and write the domain of that function. That is 2 to infinity, right? It's the x values. The x values begin at 2 and they go to the right forever. What about the range? Low to high. These are y values. The lowest y value that guy is 0. The highest y value, even though it looks like it flattens out, it really doesn't. It goes up to infinity. Now, how does that help? Well, we know when we have to answer part C, we could go ahead and do part C right now, because this is the domain and range for the f graph. What's the domain and range for f inverse? Just switch them. Let's go ahead and write that. So the domain for f inverse better be 0 to infinity. And the range for f inverse absolutely has to be from 2 to infinity. You switch those two. Why? Because the x's and y switch, and that's what we are about to do on our next step over here to do part A. So this is part C already done. Okay, well, back over here to part A. So now I have x equals the square root of y minus 2. Why did I do that? Because the second step in calculating an inverse is always to switch the x and y value. Now, your next step is to solve for y, which means all that algebra you learned before you took this class, here it comes. You've got to get this y by itself. How do I do that? Well, first I got to get rid of the square root, right? So I'm going to square both sides. I'm going to square the right and square the left. Now, this is not like when you're dealing with a square root where you have to put a plus or minus. When you square both sides, you're cool. You can just go ahead and square both sides. This cancels. Now I have x squared is equal to y minus 2. Again, I'm trying to get this y by itself. So I need to add 2 to both sides. Plus 2, if that helps you feel better. There it is. And that gives me x squared plus 2 on the right-hand side, and there's y all by himself on the I said that backwards, x squared plus 2 on the left, and y all by himself on the right. Now, if we write that in function form, that's f inverse of x, because that's what y is, equals x squared plus 2. This answers part A almost, but there's a restriction. X squared plus 2 is a parabola. The domain of that is all real numbers. But we're only allowed to graph this for our domain. Notice it says from 0 to infinity. Another way to say that in interval notation is x is greater than or equal to 0. Okay? So again, x squared plus 2, if I were to graph that, that is like this. Okay? But the inverse of a square root is going to be only half this guy. It's really only going to be what I graph here in purple right here. Okay? Imagine reflecting that through that line right there. Okay? It's going to be the graph that I just put right here. So that domain is restricted because we started with a square root. Our inverse is going to be only part of a parabola. So we have a restriction over here. And this is the booger part. This is what gets everybody on this problem. Okay, now they want us to graph f and f inverse on the same graph. I sort of did that already, but let's make it look a little bit better. So the f function, remember, is the square root moved right 2. So there it is. F inverse is x squared plus 2. So that's a parabola shifted up 2. That's what it looks like. But remember, I'm only supposed to graph it because my domain was originally my range for 0 to infinity. So I'm going to use my eraser and graph what it really looks like. Now, how do you check these graphs to tell if they're right? Remember, it should be a reflection through the line y equals x. And there you go. Part C, remember, we already did. Domain and range, range and domain. Now, I want you to see this typed up, these answers typed up, okay? Here you go. So again, notice for part A, there's our x squared plus 2 that we calculated on the previous page, right? And then there's that extra, x is greater than or equal to 0. Why? You can plug in any number you want into x squared plus 2, but the inverse of this is only the right half of that parabola when you reflect it through, okay? And then the graph, remember we talked about the graph right here. Remember, this doesn't look anything like our two graphs that we did. And again, you could check these by looking to see if one is a reflection of the other through that line y equals x. These two are not a reflection through that line. Look at B. Okay, these two guys are not a reflection through that green line. These are. That doesn't mean that's the answer, though. They could have given you at least several that are a reflection through the line, but A, B, and D are not even reflections through this dashed line right here. So we know that can't be right. So it's kind of a way to cheat yourself through there, okay? And then I didn't print what looks like the answer for C, but again, if I go back a page, remember, this is your domain and range for the F, and this is your domain and range for F inverse. Why do we know that so quickly? Because we just graphed the original function F, looked at it, found the domain, found the range, and then switched them for F inverse. And that's how it works every time. Okay? Hope this helps you out with homework, and I hope you have a great day.